Hello everyone. So today we have a question of matrix, right? So the first question says let alpha and beta be real number. Consider a 3 cross 3 matrix A such that A square is equal to 3A plus alpha I, right? It is given that A square is equal to what? 3A plus alpha I, and also it is given that A to the power 4 is equal to 21A plus beta I, right? Then we have to find the value of either alpha or beta, right? Because in the option they have given the option for alpha and beta both, right? So we have to find both and verify that whether the option of alpha or beta is correct, right? So the first thing we will start with, we will write that A square is given as 3A plus alpha I, right? The first step I am doing is I am writing just only whatever is given. A square is equal to 3A plus alpha I. Now the next step we can do, because the value of A to the power 4 is also given, right? A to the power 4 value is also given. So what we will do, we will proceed to the next power, that is A to the power 3. And how we can proceed to the A to the power 3? We will multiply A square with A, right, on the left hand side, and to balance it we have to multiply A on the right hand side also, right? So the next step I am multiplying on the left hand and right hand side with A, so it will become A cube. This will become 3A square and this will become A alpha I, right? Every single term is get multiplied by, right, A. Now here I am in this step, I can see that here it is A square. So A square can be replaced by, A square can be replaced by this. A square can be replaced by 3A plus alpha I, right? So I can replace A square with 3A plus alpha I, right? And this will remain similar, right? Now I can multiply, I can write it as 3 3s are 9A plus 3 alpha I, right? And this is A alpha I. Okay. Now we have find the value of A cube, right? Now we have find the value of A cube. The next step we have to find the value of A to the power 4. And whatever value we will get from this process, we will compare this with this one, because A to the power 4 value is already given, right? So now again we will multiply left hand side with A to the A, it will become A to the power 4, this will become 9A square, this will become 3A alpha I, and this will become A square alpha I, right? It is similar step as previous one. Now wherever you see there is A square, just replace it with 3A plus alpha I. So I am replacing it 9 3A plus alpha I, right? And here 3A plus alpha I plus 3A plus alpha I, and alpha I will be outside the bracket, right? Now just simplify it. In simplifying process, we will get 9 3s are 27A plus 9 alpha I, right? This will become alpha into I into a 9. This will become 9 alpha I. This will become 3A alpha I, and this will become 3A alpha I, and the last term will be A square I square, right? So this is the final simplification, right? This is the final simplification, and the final simplification will look like 27A, 9 alpha I, 3A alpha I, and 3 alpha I. This both term can be added up to 6A alpha I, right? This both term can be added up to 6A alpha I square is nothing but I, right? Because we know that identity matrix square is nothing but the identity matrix, right? Now what we can do, these terms, right? These two terms 6A alpha I, these three terms can be, from these three terms I can take A common, right? So if I will take A common from these three terms, I am marking it so that it will be easy for you, right? From these three terms I am taking what common? I am taking A common, so I can write it as 27 plus, I can write it as 27 plus 6 alpha and outside the bracket I am taking a common, right? Also from these two terms, what I can do, I can take common in form of alpha, because I can see alpha in both the terms, right? Alpha in both the term. Also 9, and here it will become alpha, and I can be written outside. Okay, fine. So this I can write is as alpha 9 plus alpha, 9 plus alpha, and outside the braces I can write I, right? So this is the common term which I am taking, a common, and I will get 27 plus 6 alpha. Also alpha 9 plus alpha, and I am taking as common, right? Now what we can do, this is the final simplification of what? A to the power 4. This is the final simplification of what? A to the power 4. But A to the power 4 is already given in the question, right? So now the only thing that is left is we have to compare both the values. A to the power 4, we have to compare. And how we can compare? Comparison can be done like 27 plus 6 alpha. This will become equal to 21, and also alpha 9 plus alpha, this will be equal to beta, right? I have just done the comparison, right? And by comparing I can get 27 plus 6 alpha is equal to 21. So I will find the value of alpha from here, right? So 21 minus 27, that is nothing but minus 6. 6 alpha, we will get the value as minus 6. Alpha will become minus 6 to the power 6, that is minus 1. Alpha is equal to minus 1, we got the value, but alpha is equal to minus 1 is not given in the question, or sorry, option, right? Alpha is equal to minus 1 is not given in the option. So now we have to look for the value of beta also, right? Now beta, once we got the value of alpha, we will put the value of alpha minus 1. This is 9 minus 1 and beta. 9 minus 1 is nothing, 8. 9 minus 1 is nothing but 8, and 8 minus 8 into minus 1 is what? Beta is equal to minus 8, right? So we got the value of alpha. Alpha is what? Minus 1, and beta is equal to what? Minus 8. So let's compare. Okay, in the option I can see the D option is correct, right? Because beta is equal to minus 8 given in the option number D. So here the correct option will be D only, right? Thank you.